Hello, my name is Anthony Rodriguez, and welcome to the demo for my project Fortis Budget. This is a personal finance application built with React, TypeScript, and Tailwind CSS, powered by a Firebase Auth and Firestore backend. The core philosophy behind this app is financial strength through intentionality. Most budgeting apps on the market are highly reactive. They just show you a pie chart of the money you've already spent. Fortis is designed to be proactive. We do this through a system called shields and vaults. During onboarding, users commit to shielding a percentage of their income. That money is then routed into specific savings vaults, like an emergency fund or vacation fund. Looking at the dashboard, the most critical number is going to be this green available budget card. This isn't just income minus expenses. The engine actively calculates your total net cash, subtracts the money you have safely locked in your vaults, and outputs your true spendable cash. It tells you exactly what is safe to spend today. Below that, we're going to have our budget categories. There is a custom 4-tier health tracker for your budgets. So as you spend, the progress bar transitions from a green to an amber to a red. If you go over that budget, the row is going to shift into a high contrast, kind of blackish, so you can immediately know that you went over your budget. Because the entire dashboard is heavily memoized and tied directly to the transaction state, all of these progress bars and summary cards recalculate in real time as data changes, with no need to constantly ping the database. So let's look at what happens when you get paid. When a user logs an income transaction, we don't just dump the money into a general pool. We're going to intercept it with our dynamic allocation engine. When I enter my paycheck amount and click this autofill button right here, a custom distribution algorithm fires. It loops through every active savings vault, calculates the exact capacity remaining before the vault hits its ceiling, and then distributes the paycheck to fund their monthly targets. This is going to require strict mathematical balance checking to ensure we never allocate more money than the paycheck holds, and we never push a vault over its maximum cap. Once I hit this log transaction, the money is then shielded, and my available budget on the dashboard drops to reflect my new spendable reality. So you can see I had it here, and this is what I can actually spend. You see these updated. So another one of the biggest hurdles in building fintech apps is that every bank formats their spreadsheet exports differently. Instead of relying on a bloated third-party library, we've incorporated a native CSV parser and mapping wizard. So when a user uploads a file, it's going to walk you through this mapping wizard. It's going to read the raw text and attempt to auto-guess the columns based on common bank headers. However, it displays this mapping wizard so the user can perfectly route their data, their date, description, and amount columns, even if their bank separates debits and credits or uses positive numbers for expenses. As it imports, the rows pass through a smart categorization engine. The app uses rejects to scan the payee descriptions. If it sees Netflix or Kroger, it automatically routes them into the user-specific entertainment or groceries budget buckets. If it then packages all the valid rows and sends them to Firestore using concurrent promises. Finally, we've prioritized data resilience. For example, all major account changes uses Firestore atomic batch writes, meaning if a bulk deletes fails halfway through, the whole operation cancels, so the database is never corrupted. We also recently built a network-aware safeguard that completely locks the app's autosave engine if a user logs in during spotty connection, preventing them from accidentally wiping their settings. To wrap up, the product is fully workable right now. I'm still incorporating a few features, but would love some feedback on some challenges I'm facing. Um, so right now, I'm filtering and mapping arrays entirely on the client side. Um, at what data volume would you consider offloading these to like a backend service? Since I'm using Firebase, like a Firebase cloud function, or if you have a better insight there. And then for the CSV, I just imported about 24 months worth of data. But with a lot of data, we run the risk of hitting concurrent write limits. So should we chunk the array into like 500 document batches or incorporate a queue? And then the CSV parser also handles standard messy data and inverted amounts well, but how much edge case logic should I reasonably build to accommodate like bizarre bank formats before it becomes too difficult to maintain? Those were my key points that I wanted to kind of get feedback on, but any other feedback is welcome. UI, just any other critiques, I am very open. So again, this was Fortis Budget. Thank you very much.